So, we're going to launch into the next section of this slope conversation, right? And that's expanding our equation now. So we're used to seeing y equals mx as an equation, right? We've done that a couple times. Now we're going to add in a little something else. So a linear equation, can someone read the definition for everyone real quick? Just so we can all hear it. Azalea, perfect, thank you. Awesome, thank you very much. An equation with ordered pairs for solutions that form a line when graphed. So ordered pairs, we just mean coordinates, right? Like 2, 4. That's going to be our solution or our answer for a linear equation. Okay, and we've seen all this already. We're kind of just rephrasing it because the tables that we were working with, thank you, sir. The tables that we were working with on our worksheet that we just went over, these are all ordered pairs, right? These are all pairs of points. We plotted them on this graph. 4, 3, 8, 6, 12, 9. We plotted all those points on this graph, right? So a linear equation, all of its solutions are ordered pairs, just like we saw in the tables. And when we graph them, it's going to form a line. So here is our linear equation formula, all right? Y equals m times x plus b. Y equals mx plus b. Great question. We'll get to what b stands for here in a second.
Okay.
So let's break down what each of these variables means, because I don't know about you, but I don't see any numbers in that equation, and that kind of freaks me out.
Me too. I do. Oh, I see 1.
So, m, as we know, is our slope. Right? M is our slope. B is a little something called our y-intercept. Has anyone ever heard the term intercept before?
I have.
Jordan's heard it. Anyone else heard of the word intercept? Okay, a couple people. Where have we heard the term intercept before?
Football.
Football, what do you mean? Explain. I know what you're talking about, but explain to everyone.
Like in Patrick Mahomes, like in Fortnite.
Okay, hold on one sec. So, phrase on real quick. What is an interception in football?
When the quarterback throws the ball to his receiver, but the receiver doesn't catch it, but instead the cornerback catches it, and then the other team has possession of the ball.
Oh, I see. So if it was like me and Max are on a team, right, and I'm the quarterback, I'm throwing Max the ball, and then Elizabeth jumps up in the middle and catches it and starts running the other way.
Oh, the change of possession.
Change of possession. Yeah, exactly.
That's a pick 6.
So that right there would be an interception, right? In math, it's kind of along the same lines. So a y-intercept, if we have a graph, to intercept something is basically just to get in between of, right? Just like if I'm throwing the football to Max, Elizabeth jumps up in between us and picks that ball off. If we have a coordinate plane here, right? Here's our y-axis. The y-intercept represents the point on a line that intercepts or crosses the y-axis. So if we have a line here like this point right here is B. That's our y-intercept. So if that point is up at 4, then our B is equal to 4. So, it's okay. This is going to be confusing. That's why it's broken down a lot, and we take a lot of time. So the y-intercept is the point that intercepts or intersects, you could even say, the y-axis. So a point that's over here can't be the y-intercept. It doesn't touch the y-axis. So any point on this y-axis is going to be a y-intercept. But we'll talk more about that later. And then x and y, this represents any solution to this equation.
Somebody's playing video games.
Okay, whatever that noise is, please stop it. Okay, we're taking notes. So this represents the x value of any solution, and y represents the y value of any solution. So 4 different variables. They all represent a different part of our line. But when we have an equation written in this form, it's basically just the mathematical way to represent just a line. So when you see something in this form, it just means it's a line, a straight line on a graph. Go ahead and add in a little note here. When b is equal to 0, the relationship is proportional. Oh, sorry, I'll move this down. When b does not equal 0, when b does not equal 0, the relationship is non-proportional. Okay, just something that's good to know. Yes. Oh, that's what I'm saying. Yes. Yes. What does it mean for our b value to equal 0? Well, let's take a look at a graph. If we have this graph here, b represents where that line intercepts the y-axis, right? So this y-intercept's got to be somewhere on this line. Where on that line are we going to get a y value of 0? Or sorry, a b value of 0? Well, right in the middle, at 0, 0. And we could have a line that looks like this. We could have a line that looks like this. Or a line that goes all the way through the graph too. If it passes through the origin, it's proportional. And when it passes through the origin, our b value is 0. Okay? So again, a lot of this stuff is going to make more sense the more that we actually do it. Don't feel too stressed out if you don't quite get it just yet. Because now we're going to look at an example and hopefully it'll make some more sense. So example A. Example A, we're going to use the equation y equals 2x plus 1. Okay. Everyone got that written down? Are we still right? So real quick, I want to show you just a visual of what this is going to look like, okay? So, here's a graph. And here's the line y equals 2x. If we zoom in here, we can see that our slope here, if we start at the origin and end at this point, we rise up 1, 2, and we run over 1, right? So our slope would be 2 over 1, which is 2. Y equals 2x is in the form that we want, this linear equation form. Y equals 2x. Now we don't have a b value, but that's because this line goes through the origin, right? So our y-intercept is 0. What if we changed our equation to y equals 2x plus 1? What happened to our graph there? As a matter of fact, let me write a different one. Y equals 2x plus 1 in blue. So what happened to our line? Jordan, what happened to our line? It moved in what direction? It moved up, right? How many units did it move up? 1 unit. What if we did 2x plus 2? How many units did that move up? 2, right? And if we did 2x plus 15, look at that. The line goes all the way up to 15. But let me ask you this. Does the slope of our line change?
No.
No, it's the exact same slope either way. The only thing that changes is where this line crosses the y-axis. Right? Let me add in that other equation here. 2x plus 1, and then there's y equals 2x plus 3, and then y equals 2x. Let's just do plus 10. So 4 different lines here, right? They all have the exact same slope. They're all going at the exact same angle. But this one crosses the y-axis at 0. The blue line crosses at 1. The green line crosses here at 3. And this purple line crosses at 10. All we changed was that number we're adding on the end. You guys see what I'm saying with that? Hopefully. So if we have y equals 2x plus 1, do we just have to... Oh, okay, I see what we're going to do. We're going to fill out the table. Yes. Yeah, come on up. You got one? Okay, thank you, Leslie. I only have really tiny Band-Aids. Real quick, let me see what IXL wants you to do. I already forgot. Okay. So, first thing we're going to do is fill out this table.
That's nasty.
I forgot we used distance yesterday.
You're not washing your hands? I did. Then why is there still blood in your hands? I should know.
All right.
It might also be.
Go ahead and draw this table.
Oh,
And for your x values, I want you to put 0, 1, 2, 3, 4.
What does the fuck say?
So we're going to find our y coordinates here on the table. And how we're going to do that is we're going to take our initial equation. We're going to take each of these given x values. We're going to plug them in for x. And we're going to get our answer for y. Here's what that's going to look like. Our first x value is 0. So we'll do y equals 2 times 0 plus 1. Right? All we did was swap out the x for a 0. Now we're going to go ahead and solve. 2 times 0 gives us what? 0 plus 1, right? What's up?
Can I get some tape? Because my notebook.
Yeah. Oh, there's it. So we plugged it in for x. We multiplied 2 times 0 and got 0. Now we just have to add up 0 and 1. What's 0 plus 1? 1, right? So we plugged in 0, multiplied 2 times 0, and then added 0 plus 1. Now we've got our y value when x is equal to 0. Now let's figure out what our y value is going to be when our x is 1. We're going to take y equals 2x plus 1 again. But now for x, we're going to plug in 1. So we plugged in 1 here. We multiplied 2 times 1, and what do we get? 2 times 1 is 2. And then 2 plus 1 gives us a y value of 3. Everyone with me so far? No? No one's with me?
Yes.
Okay.
I'm with you.
Let's plug in the next one. We plug in 2. 2 times 2 gives us 4. 4 plus 1 gives us y equals 5. Now think about this for a second. Is there another way that we could have filled out this table without doing all this math?
Yes.
Yes? What could we have done? Okay, Jordan, you got an idea? What could we have done?
The y after you did the 3 is like plus 2.
Oh, so you're saying once we got these first two y values, 1 and 3, we could say, hey, look, our change in y is plus 2. Let's just keep going plus 2, plus 2, plus 2. Is that what you're saying, Jordan?
Yeah.
Perfect. That's exactly what I was thinking about. We could have used our change in y. Matter of fact, we didn't need to do any of this math. Right? When x is equal to 0, that tells us what our y-intercept is. As you can see, our y value here was 1. And in our equation, our b value, or our y-intercept, is 1. Right? To get from 1 to the next point, we need to know what our change in y is. And we see here from this slope that our change in y over change in x is 2. So if we're changing this one by 1 each time, we would need to change this one by 2. So all of these things that we're learning are all connected. I really hope you guys are at least starting to see the connections here. So without doing all this math, if we keep going, what's our y value going to be when x is equal to 3? 7. We're just going to add 2. And what about when y is equal to 4? Or sorry, when x is equal to 4? 9. Exactly right. Now let's go ahead and graph this real quick. So we're not going to make this a whole big thing. It doesn't have to be crazy, the graph. Just make a little L like this, with at least 1, 2, 3, 4 notches on each one. Just like that. So let's go ahead and plot our 2 points. We got a point at 0, 1. Boom, right there on the y-axis too. See that? Whenever we see an x, or whenever we see a point where the x-coordinate's 0, that's our y-intercept right there. And then we could plot 1, 3. If we wanted to, we could do 2, 5 as well. It would be like up here. And if we connect all those points with a line, we see that, yes, this is in fact a linear relationship. It's a straight line. The last thing we're going to do is identify the relationship. Is it linear? Is the graph that we just drew there linear? What do you think? Yes, I would say that it is. It's a straight line. So we know that it's linear. Now we're going to ask, is it proportional? Linear is half of the job with being proportional, right? But is this proportional? No, I hear a couple people saying no. Why do you say no?
It doesn't go through the origin.
That's right. It doesn't go through the origin. So what we have here, we can describe as, this is a linear, non-proportional relationship. How are we feeling about that? I know it's kind of a lot. Probably a good amount of you probably have some brain fog from that right now. But once you guys look at the IXL, trust me, you're going to be like, oh, this isn't as hard.